Next, let's talk about Amazon OpsWorks. OpsWorks is a configuration management service that provides managed instances of Chef and Puppet, which are popular automation platform. OpsWorks enables you to manage and automate the deployment and configuration of your applications on AWS. With OpsWorks, you can create the custom stacks that define the resources required by your application and automate the process of deploying, scaling, and monitoring those resources. OpsWorks has a few core components like stack. A stack is a collection of resources that are created and managed together as a single unit. You can use a stack to create, update, or delete a group of resources at once. A stack is created from a set of configuration files that define the resources and their dependencies. A layer represents a set of resources that perform a specific function, such as running web servers, application servers, or databases. Layers can contain EC2 instances, Elastic Load Balancers, and Amazon RDS instances. Instances An instance is a virtual machine that runs the software for a particular layer. Instances are created and managed by OpsWorks, and you can configure them with custom recipes and scripts. Recipes. A recipe is a set of instructions that configure and deploy software on an instance. Recipes are written in the Chef or Puppet automation language and are used to automate the installation, configuration, and management of your application. An app is a code repository that contains the source code for your application. OpsWorks can pull the code from Git or AWS code commit repositories and deploy it to your instances. The OpsWorks workflow consists of the following steps. Creating a stack. Use the AWS Management Console, CLI, or SDK to create a stack. A stack defines the AWS resources that your application requires, such as EC2 instance, load balancers, and RDS instances. Define the layer. Define the layers that your stack will contain, such as web server, application server, and database. Each layer contains one or more instances that run the software for that layer. Add instances. Add instances to each layer in your stack. You can use the OpsWorks to automatically launch the instances, or you can add the existing instances that you have already launched. Deploy the app. Deploy your application code to your instances. OpsWorks can pull the code from Git or AWS code commit repositories and deploy it to your instances. Configure the instances. Configure your instances using custom recipes and scripts. Recipes are used to automate the installation, configuration, and management of your application. Scale your application. Use OpsWorks to scale your application up or down by adding or removing the instances as needed. OpsWorks is actually used to automate the resource provisioning on the AWS environment. There are multiple practical use cases of Amazon OpsWorks that include deploying the web application. You can use to deploy and monitor the web application, including popular web applications frameworks such as Ruby on Rails, Node.js, and PHP. Managing the infrastructure. You can use the OpsWorks to manage the infrastructure resources such as EC2 instances, Elastic Load Balancers, and Amazon RDS. Application deployment. OpsWorks can be used to automate the deployment of the applications, including building and deploying the code, maintaining the dependencies, and configuration servers. Next, let's talk about AWS organizations. AWS organization is a service that allow you to consolidate multiple AWS accounts into an organization that you can centrally manage and govern. It simplifies the management of your AWS resources and enables you to govern your account with fine-grained control. With AWS organization, you can create an organization, invite other AWS accounts to join, and then organize those accounts into hierarchies that you create. AWS organization is a service that allow you to consolidate multiple AWS accounts into an organizational structure, which can be used to apply policies and settings to groups of account. AWS organization allow you to create and manage a hierarchy of account with parent and child accounts. This hierarchy allow you to apply policies and setting at different levels, such as at the organization level or at the individual account level. AWS organization also provide consolidated billing, which allow you to consolidate billing across all accounts in the organization. Here are some of the core components of the AWS organization. Root, the top level container of all the accounts that are part of the organization. The root is created automatically when you create an organization. Organization unit, a container for accounts that you want to group together for management and governance purpose. You can create organization unit to mirror your organizational structure, such as by department, business unit, or location. Account, an AWS account that is part of your organization. Service control policies, SCP or service control policies that you can apply to organizational unit or accounts to manage permissions and access to AWS services and resources. SCPs act as a guardrail to help you enforce policies for your organization. Tag policies, a policy that you can apply to your organization to help enforce tagging compliance across your accounts. Tag policies enable you to standardize tag across accounts and ensure that resources are properly tagged. Here is a simplified workflow of the AWS organization. Create an organization. First, you need to create an organization from the AWS organization console or using the AWS CLI. Invite accounts to join the organization. You can invite the existing AWS accounts to join your organization. Accounts can accept the invitation using the AWS organization console or CLI. Create OU. You can create the organizational unit or OUs to group accounts together and apply the SCPs or tag policies. Apply policies. You can create and apply the SCPs and tag policies to OUs or accounts to govern access to AWS services and resources. Monitor and manage your organization. You can use AWS organizations to monitor your organization's compliance with policies and manage your accounts centrally. Some practical use case of AWS organizations include consolidating the billing and cost management. AWS organization allow you to consolidate the billing across your accounts, making it easier to track and manage the cost. Let's say if you have multiple AWS accounts in your organization, instead of paying the bill of each individual AWS account, you can create the AWS organization and consolidate the billing of all the AWS accounts and pay in one bill. Centralized governance and compliance. AWS organization provide a centralized way to enforce policies and compliance across your accounts, enabling you to ensure consistent security and governance. Simplified management of large scale deployments. If you have a large number of AWS accounts, AWS organization can help you manage and organize them more effectively. Next, we will discuss about AWS Cloud Formation. AWS Cloud Formation is a service offered by AWS that allow you to automate the creation and management of AWS resources. With Cloud Formation, you can create the templates that define your AWS infrastructure as a code and then use those templates to create and manage your resources. Cloud Formation is a service that allow you to model and provision the AWS resources in a declarative way, which means you specify what you want to deploy and not how to deploy it. This allow you to automate the creation, modification and deletion of your infrastructure in a consistent and repeatable way, so you can automate the deployment, configuration and management of the AWS resources. Instead of manually creating and configuring each resource, you can define them in a cloud formation template, which allow you to launch and manage the resources in a single stack. Cloud formation consists of four core components. Templates. Cloud formation templates are JSON or YAML files that describe the AWS resources that you want to create and how they are related. Templates are used to create, update, or delete a stack, which is a collection of resources that are provisioned together. Templates include resources like EC2 instances, load balancers, RDS databases, and many more. You define the resources in templates and CloudFormation create those resources for you. Stack. CloudFormation stack are set of AWS resources that are created and managed together. A stack is created from a template and can be updated, deleted, or recreated as needed. Stacks enable you to manage your infrastructure as a code and simplify the resource management. You can also use the CloudFormation stacks for rollback, which means you can revert to a previous version of your infrastructure if there are any issues with the current version. Change set. CloudFormation change set allow you to preview changes to a stack before applying them. This is useful for reviewing the impact of changes, verifying that your infrastructure will be updated as intended, and avoiding the unexpected consequences. A change set includes the difference between the current stack and the proposed changes, such as adding new resources, modified the properties, or deleting the resources. Resources. CloudFormation resources represent the AWS resource that are created and managed by CloudFormation. Resources can be created, modified, or deleted as part of a CloudFormation stack. CloudFormation supports a wide range of AWS resources, including EC2 instances, S3 buckets, IAM users, and many more. CloudFormation workflow consists of the following core steps. Creating a CloudFormation template. First, you need to define the resources that you want to create on the AWS in a template file. Creating a JSON or YAML file that describe the AWS resources you want to create, modify, or delete. You can either write the templates from scratch or use an existing template as a starting point. Uploading the template to AWS. Once you create the template, then you need to upload the template to S3 bucket or use a local file path. Use the AWS Management Console, AWS CLI, or AWS SDK to create a stack from the template. When you create a stack, CloudFormation provisions the resources defined in the template. Update a stack. You can use the AWS Management Console, CLI, or SDK to update an existing stack with changes defined in new template. CloudFormation applies the changes to the stack resources as needed. You can delete the stack and its associated resources. CloudFormation remove the resources provisioned by the stack. Use CloudFormation change set to preview the changes to a stack before applying them. This allows you to review the changes and ensure that they will have the desired effect on your infrastructure. So this is the workflow of the CloudFormation. To use the CloudFormation effectively, it is important to understand how to write and work with templates, how to create and manage the stack, how to use the change set, how to interact with the CloudFormation resources. You should be familiar with CloudFormation best practices such as versioning your templates, testing and validating your templates, and organizing your stacks. Next, let's talk about AWS Control Tower. AWS Control Tower is a managed service provided by AWS that helps organizations set up and govern a multi-account AWS environment. It simplifies the process of creating the new accounts, configuring the security and compliance policies, and managing the resources across accounts while maintaining the desired level of security and compliance. AWS Control Tower is a service that builds on top of the AWS organization and provides additional functionality to simplify the management of a multi-account AWS environment. AWS Control Tower includes pre-configured templates and policies called guardrails that are designed to enforce best practices for security and compliance. It also includes a pre-configured landing zone, which provide a baseline environment for deploying workloads in a secure and compliant manner. AWS Control Tower also include a centralized dashboard for monitoring and managing the environment, which provide visibility into compliance and security across all accounts. AWS Control Tower consists of several core components, including landing zone. This is a foundation of the AWS Control Tower environment. It is a pre-configured set of AWS accounts, networking, and security setting that provide a secure and compliant baseline for workloads to be deployed. Guardrails. These are pre-configured policies that enforce best practices for security and compliance across accounts in the landing zone. Guardrails can be customized or created from scratch to fit an organization's specific need. Blueprint. These are reusable templates for provisioning and configuring the resources in AWS environment. Blueprints can be created and shared within an organization, providing a consistent and repeatable way to deploy the workloads. Organizational unit. These are logical grouping of AWS accounts within the landing zone. They can be used to apply policies and setting to specific groups of account. The AWS Control Tower workflow can be broken down into the following steps. Setting up the landing zone. The landing zone is set up using the CloudFormation template provided by AWS. This creates the foundational account and resources necessary for the landing zone. Configure guardrails. Guardrails are configured to enforce security and compliance policies across all accounts in the landing zone. These policies can be customized to fit an organization's specific need. Create OUs. OUs are created to group the accounts together based on the business needs. Policies and setting can be applied to OU to ensure consistent governance across accounts. Provision resources. Blueprints are used to provision and configure the resources within account. These resources are deployed in a secure and compliant manner as defined by the guardrails and policies. Monitor and manage. AWS Control Tower provides a centralized dashboard for monitoring and managing the landing zone. This allows the organization to easily monitor compliance and security across all accounts in the environment. Monitor and manage. AWS Control Tower provides a centralized dashboard for monitoring and managing the landing zone. This allows the organizations to easily monitor the compliance and security across all accounts in the environment. AWS Control Tower can be used in organization to ensure that all workloads are deployed according to the best practices. It can be used to ensure that security and compliance policies are enforced across all accounts. AWS Control Tower provides a consistent and repeatable way to deploy the workloads while maintaining a high level of security and compliance. There is no additional charges for using the AWS Control Tower itself, but organizations will incur the charges for the underlying resources used, such as AWS accounts and services.